Okay, so we'll finish the material for controls, and I said it will cover a lot of the material in chapter 13. Chapter 13 addresses a lot of the electronics. I just want you to get exposed to it, so don't get frustrated by the names of the components we're going to talk about now. But at least if you go to a company that manufacture or maintain those controls, it will be nice to know the names of it, or have an idea of what are they. So CAD cell primary control, we talked about that last week, and we are working with that in this lab. So the CAD is cadmium sulfide resistance that it changes with light. So cadmium sulfide, somebody realized that this material, it reacts with the photons coming from light. So when you make light, light bulb, or fire, what's making the light? So light is a component of photons. Photons are particles coming out of the light, and there's also a wave. Light is also a wave. So again, I'm not going to go too scientific about it, but light does emit small little particles called photons. That's why they also have something called solar sails, a big sail that get propelled by light. And there are some experiments where you can push things that require very low resistance using photons. Because when you emit light on something, you're actually pushing it a little bit. There's something that's being thrown at it. So something being thrown at it. So that's photon. So those photons can react with cadmium sulfide and happen to have lower resistance. So when we tested the CAD cell yesterday in the dark, what was the resistance? Very high.
Yeah, over 10,000.
Over 10,000. Remember that. This number is going to be on the oil burn exam. The CAD cell resistance in the dark is more than 10,000. Could be 40,000, 50,000, but more than 10,000. In the light, what should it be?
It was like, it was way less.
Huh?
Less than 10,000.
Less than what? Not 10,000.
1,000.
Huh? Less than 1,000. Less than 1,000. Could be 30, 40, 50. The amount of resistance kind of tells you how much light is there.
And then I think in old TVs you can see like the wave.
Okay, so when there is no light, there is no flow of electricity that takes place because the resistance is too high. So basically the CAD cell acts as a switch. We have to run current through it, and if the resistance is too high, it's not going to go through. Make sense? It's too high.
But you still can't jump them.
You can't jump because you don't have enough voltage. What is the voltage going to the CAD cell? Very small.
Yeah, because
24.
It's got some resistance.
Yeah, but not a lot.
It's
Yeah.
got none. Then
If you have 10,000, it's not going to go through, so it's going to be dead. When there is no light, there is no flow of electricity, and the safety switch will think that there's no light, no flame. So the delay is from 15 to 45 seconds. 45 seconds to prove the flame. So we're going to turn the burner on, turn the gas on, and wait for 15 to 45 seconds. Why do I give you a range? Because last year is 15 seconds. The year before it was, the code was 30 seconds. The year before it was 45 seconds. If you have a 45 seconds primary control, an old one, probably is grandfathered in, it's going to be there. But the new ones are going to be all 15 seconds. Some of those advanced or new ones are programmable, so you can change the timing in it for the delay. So this time means that how much time do I have to prove the flame? I have 15 seconds to see flame, or I'm going to put this control in safety and shut everything down. So 15 seconds, I think it's enough. 45 seconds is a lot because you're going to be dumping a lot of oil inside the tank. And if you do that 3 times, probably there's a lot of oil saturated and sitting inside the tank. And when it turns on, it's going to light up.
Now, that is a
Question?
lot of
Yeah.
oil.
Huh?
That is a lot of oil.
Yeah. Well, if you think about the size of the nozzle is going to dump 1 gallon per hour. So for 1 minute, that's 1/60 of the gallon, which is not a lot, but it's still something. Probably an ounce or something. That's a lot. Over time, it can accumulate. So there's also a way to detect electricity using PV. What is PV short for? Photovoltaic. It's the stuff you have in your calculator. It's the stuff you have in your roof of your house. Photovoltaic. You're gonna ask me to write it because I don't think I can spell that. But photovoltaic cell, it produces electricity, unlike cat cell. Cat cell changes resistance. PV produces voltage. This voltage is a function of how much light is hitting it. Is it AC or DC? DC. It produces DC power. There are also infrared detectors that will sense IR in the flame, and we say whenever we have visible light, there is infrared and there is ultraviolet. Can you put the phone away, please? And we also have thermocouple, which also produces voltage, similar to PV, in a small amount, and it's also direct current. So let's just sum it up. What are the means to detect heat? Thermocouples, photovoltaic, infrared, UV, and CAD cell. So all these, except for this one, they're called optical. Why? Because they have to see the light. It's about visual.
So you're saying these detect heat because of other properties that are from the flame?
Yeah.
Okay.
Yeah. This one detects heat. Flame rod detect ions. The other ones are opticals. They just see the light. They look at the light. That's why they call it optical, and that's why sometimes they put a magnifying glass on it so you can absorb how much light comes from the fire. Questions so far? If you can just remember the cadmium for now, these we're going to cover in a lot of details in commercial. For now, in a house or residential boiler, we're only going to use CAD cell. That's the official one. And we learned in the lab how to test this CAD cell, and you see how sometimes by looking at it, you can see if it's broken, if it's burnt, and you can test the resistance and see if it functions properly or not. Okay, so I'm gonna go over chapter 13 in the book. I'll highlight the things that you need to have an idea about. Don't get frustrated by the names or the details, but I want you to understand semiconductors, how do they work, how do they make these boards. It will be nice that you went to college and you know what small things are called and what do they do. We don't have to know how they are fixed or how they function in detail. You can tell this is a capacitor, this is a relay, and if when confused, what are you going to call something in a board? IC, integrated circuit component. So that's the layman term for any component in a transistor board. When I used to go take my VCR to the electronic shop and it breaks, and I tell the guy, what broke it? He will tell me, an IC. Okay. An IC is something. Every time it's an IC, it's like, how many times this IC breaks? 15 minutes an IC. And he charged me like $20. IC, okay. So how many ICs are there? They're all IC. Show me the IC that breaks all of that. They're all ICs, integrated circuit component. I had students who went to interview for a job and they asked him, what's a diode? I don't know, but we'll find out now.
One direction.
Yes? But we're gonna say that we covered it at least. So we'll talk about the operation of basic electronic systems, components, describe the operation, what do they do. We can trouble some kind of one function components, but again, there are some people who have the patience to go with a magnifying glass and small, tiny multimeter and test all those components, and they can fix boards, depending on the cost. Now it just costs too little to change the whole thing than to pay somebody $60,000 an hour to go and troubleshoot those boards. However, some sophisticated boards, you will pay somebody to fix it. Like for example, this one is $200. If I have one of these, this is $4,000.
4,000?
Yeah, when at its heyday. But now you can buy this from Amazon.
Can I see the front of it?
Yeah, this is fire eye control. So these actually get sent out, and they have somebody who will go and troubleshoot them. Yeah, and it's very involved, and probably they have schematic where everything goes, what is the resistance. So they will do something that you will do with the board, the big board, but in a small scale. They'll go and test the voltage for each one of those, test the resistance, and they found which integrated circuit is not functioning. And I think this one I also have cartridge. What does this remind you of? You will know. Remember the Atari?
Oh.
They know what I'm talking about. Yeah. I think it's a card. And you have to blow, I don't know why blowing in it like works. So we stick.
Can I get it moist?
I don't know. 4 of us will keep blowing at it and do some prayer for it to work. And over time, it worked, and you get pixelated, and you take it out, and you wait a little bit and try to like talk to it so it will work.
Use an eraser.
Yeah, we come up with a lot of inventions. Eventually, you'll have to buy the other one, especially if you buy the knockoff game. Knockoff game is going to work as well as the original games, which cost a lot of money. Remember, how much was the VHS when it first came out? The tape. When you want to buy a tape?
Just the tape? Like
Yeah, not empty one. Like let's say you want to buy a movie on VHS.
What is it? It's like 50, 60
Yeah,
more.
it was expensive.
Buy a movie, yeah.
It was $50.
How long did that last? 10 years? 10, 15 years?
Okay. So key terms: anti-short, cycling timers. So timers also give the circuit some kind of time to not be shocked. So it will introduce the current into the circuit slowly. There's also a defrost model that you're gonna work on with Bill. These are in most freezers and air conditioners. Because over time, depending on the dew point, humidity, and temperature, you might start to accumulate frost on the evaporator or in your freezer. At some limit, you should shut off the compressor and start the defrost cycle, which heats the defrost, and the ice will break and fall. We'll talk about diode. In a nutshell, if you can't remember, the diode is the equivalent of a check valve for current, which means it makes the current go only in one direction, not the other way around. So only
For
goes.
example, if you want to branch off a circuit, but you
Yeah.
don't want it to go that way.
It's also used heavily in changing AC to DC, because AC goes up and down, right?
So it makes the current go one way?
One direction, yeah.
Are diodes also used for and/or functions?
Yep.
Okay.
Electronic module, that's a general term for the whole board or the silicon wafer, which we just looked at. Electronic motor overloads. Those also measure the waves of current, and it will shut off the motor at any chance of overload. So if you can write this down, hopefully you remember them one day if you have to. Let's skip the other one. So, light emitting diode. This has been here since the 60s. What is that stands for? LEDs. Yeah. So LEDs has been here forever. However, the light that used to come from LED was very dim. Just to tell you that this sub-circuit is on or off. Somehow somebody came up with an idea to make those brighter, and they're working on it, and now it's the dominating light fixture all over the place. Rectifiers. Rectifier is if you look at the end of the book, there's a definition for all these things. We'll actually have it in the further slides.
In the book you gave us, or the electricity?
The electricity book. There's a glossary here at the end that will give you the definition. But I'm going to give you the layman term for rectifier. It's a device that is used to change AC to DC. Solid state, what does it mean?
moving parts.
No moving part, thank you. Like a flash drive. In comparison to a hard disk that has a spinning part in it.
Solid state relays.
Yeah. Solid
Very,
state
very
relay.
common.
AC to DC rectifier?
Yeah.
Just want to mention everything.
How do
that
you
we
call
teach.
another one from
Yes.
DC to AC?
Huh?
How do you call another device, change it from DC to AC?
How does it do that?
No, do we have another device?
Yeah, we have a transformer, like your phone charger has a rectifier in it. It's changing AC to DC to your phone. Also, we have the flaming rods, which actually changes AC to DC. The photovoltaic cell does the same thing.
No, my question.
Yeah.
Can we change DC to
Oh,
AC?
yeah, you can. Yes, you can.
Think of your alternator.
Yeah, you can. You can do the same thing, but a different configuration. But you can also do that. Because if you think about it, what you want to do for, if this is AC, so it goes from plus or minus, up and down. And if we have our DC line here, which is constant, a rectifier with a diode will shave off this top only. And this will not go away. So the diode will only take the ones going up. So you're gonna have peaks, and you combine those into a circuit where you get only the peaks and make them constant. Put them in an amplifier, small amplifier, and it will go into becoming DC. And you also have to reduce the DC to the right amount of voltage. What's a semiconductor? So we talked about conductors and insulators. What is semiconductor?
Layered materials that make an effect
Yeah?
by putting electricity to it.
That's good. That's actually, that's very
Put
close.
electricity to it, and the layer changes and produces on the outside.
Okay, that's pretty close.
Instability is between, like a current between insulation and metal.
No.
That's here.
Basically, diode is semiconductor, right?
Yeah. What's that? So semiconductors,
Electrical conductive is between that of an insulator and a metal.
okay. So it's not a conductor, it's not an insulator, it's a material. If we put current to it, like let's say here, it's non-conductor. But if you activate it with electricity, it becomes conductor. So it conducts once it's electrified. If you put like electricity to it, it becomes conductor. So it kind of become like a valve, right? You turn it on and off.
It's like transistor.
Yeah, that's
That's what you said.
transistor is the general term for all these stuff. Like diode is a transistor, all these are transistors. Small little components.
Since it can be made with a layered material, it can be made very, very small.
Yeah, yeah.
Like one wafer might have
Because-
thousands of.
Think of it as a very, very, very small switch. So let's look at the definition here. If you want to look at the transistor, for example, go to T.
Electronic device. Transistor is electronic device.
So transistor is a semiconductor device used for control and amplification of a signal from one circuit to another circuit. So it's a general term for all these little components of solid state. Triac, I will show and explain that to you. What does it do? It's kind of similar to the diode. Varistor, we'll talk about it now, and we'll talk about voltage spike as well. So these used to be the amplifiers in the past. I think this is a vacuum
Tubes.
tube, yeah, where you can amplify the signal or change the signal. Look how it might change to semiconductors here.
Still much better in music.
Yeah.
Use
It has its own
for amplifiers.
appeal, yeah.
A lot better.
What is that? The Macintosh amplifiers, the vacuum tubes.
You know, PV, the amps for
Yeah.
people playing guitar or
Yeah.
harmonica, the tube amps are the best.
I gotta ask Bill about that. So the vacuum tubes, they have mechanical, and we have mechanical relay after the vacuum tubes. Then we had semiconductors and diode, which is very small. And you can see it always has three, not always, but most of the time it has three connection. One of them to activate it, and one of them to conduct, to give us the ability to make decisions. Semiconductor is a solid state. That's the physical description of the component. No moving part. You want to go back?
Can you go back one more?
Sure. Components, more components. Don't be alarmed if you can't remember these things. Again, it's not going to be our core work, but it's good to hear about it at least. So,
Well, they're on the prints for, HVAC, you can see these on the print, so it'd probably be a good idea to know like what the,
yeah.
what the
So it
symbol,
doesn't. So it doesn't.
symbol is.
So it doesn't look alien to you when you look at it. Okay, I know what this means. Maybe they didn't work on it, but I know what this means. Guys, can you put the bottom of it, please? So these are some of the key terms in this chapter. Got it?
Yeah.
I just need the next one.
So we start with vacuum tubes, mechanical relays, then semiconductor. Things are getting smaller and smaller and smaller. Again, I like to use the VCR because I have a intimate relation with my VCR. First one was this big and heavy. Everything is mechanical, expensive. It gets smaller and smaller and smaller and smaller. And then you can buy a VCR for $50. But as big as the tape.
Brand new.
Actually, but that time the DVD came up. Now they don't even have DVDs anymore. Blu-ray? What is the new thing now?
Streaming thing.
Nobody does Blu-ray anymore?
Yeah, Blu-ray DVDs.
Do you get streaming as with the same quality as Blu-ray?
TVs, there's no need for
The smart TV,
Actually, Blu-ray and 4K. Like I've got a couple of Blu-ray films that play them on my Xbox, and they're like pretty similar to 4K.
Now you just do
The
streaming.
difference is so small. I think you get more audio quality from Blu-ray than 4K.
Those are disc or like,
Disc.
I think it's changed a lot. I still have VHS.
Yeah, I'm one of those.
Semiconductors.
the original Spider-Man.
Semiconductors, it's the electrical conductivity of material. Plays an important part of semiconductor action, which basically, as Louis said, it's not conductor, it's not insulator, it's in the middle, which means that if it's activated, once it's electrified, it's going to be a conductor. So it's kind of works like a switch, on and off, which help us make more decisions. Which means like, okay, go or no go, on and off, and so on. Good conductors, copper, silver, aluminum. These boards probably have a lot of platinum and gold in them for easy conductivity and small size. Your computer processor, mostly made out of gold. That's why it's very small and expensive.
So is copper wire a semiconductor?
No, it's a conductor. It's conductor. It's good conductors. Poor conductor, plastic, glass, and mica, ceramics, and semiconductors, silicon, wafers, components, huh? Yeah. And what else? Some ceramics are also considered semiconductor. That's why if you look into the sports, I don't think it's ceramic one, but you can see sometimes a ceramic lentil-shaped IC, which also is a semiconductor. So diodes and rectifiers. The simplest of solid-state components are diodes and rectifiers, and those again change a lot of things. And I talked about this igniter, which is lightweight, very cheap, and it does change the voltage to 10,000 or 15,000 volts, which basically a bunch of rectifiers and semiconductors and amplifiers to change the voltage. And on the other hand, we have the old-fashioned 10-pound, I think it says 10-pound transformer, which is basically a wire and induction coil. So that's components with less than 1 amp, very, very small. So we have less amperage. Those boards require less energy, less battery to do the control. Because control, again, is not doing work. Control is making decision making. It's kind of like the brain. Your body's doing the work, muscles doing the work, but your brain is doing the decision making. Rectifier have similar components, but it's rated above 1 amperes instead of a diode. So a diode and rectifier kind of like the same function. rectifier is more than 1 amp, diode is less than 1 amp. A rectifier is the same thing. That's why we use a rectifier to change AC to DC, because usually we have more than 1 amp. And with a diode, usually it's used in small boards where the amperage draw is very small. Good? Look. Oop. Take your time.
Oh, so rectifier is the same thing as a diode?
Yeah, it gets bigger.
Oh.
You said a rectifier is just bigger?
No, the rectifier is bigger than diode. Has more than 1 amp.
It has more, actually has more than one diode too.
Yeah, could be.
Maybe 4.
Yeah, I will show you a picture. That is correct. And also, between a diode and rectifier, it's kind of the comparison between a relay and a contactor, right? What's the difference between a relay and a contactor?
20 amps.
20 amps. Contactor 20 amps, which basically is a relay.
And Bill says 25 amps.
Okay, one hand is supposed to have 5 amps. What does the book say?
Well, it matters what I say on the test, and he marks me wrong for it.
That's his class. I go with the book.
Right?
The book says 20, I go with 20. Okay, transistors. Don't try to remember all this, but there are, again, semiconductors. There's an N-type and P-type based on how they pass current, just to give you an idea. And I like how you remember.
That's easy to remember. that.
Don't remember that, but at least you know what it means. So for transistor, there's an N-type and P-type, and that's actually made for decision making. Something called the AND gate and the OR gate, the logic inside the board. So, based on the component of the transistor, it can let the current go or not based on the input. That's why traces hit. Some rectifier has more than 1 diode in it and more than 1 input. That's the reason. So, let me explain a little bit, just for sake of information. So, there's something called the AND gate. Ian, can you see this? Aiden, is it clear? Or should I get another pen? Huh? I'll go over there.
If I remember correctly, takes- it takes 2. Hold on a second. I got you, bud. I got you. Hold on. Okay. Is it any better? Can you see that?
And what's up my video, man? I'm gonna put that on YouTube
No,
now.
that's not gonna work. Oh, dude, you got it. Don't worry.
I need a lot of thumbs down now. You're gonna lose my fan base.
I am watching this episode.
It's not gonna go viral now. See, it's ruining my future.
Nobody wants this.
So, and for this to pass current, both this has to be on together. If one of those are off, then this is not gonna work. So AND means both have to be on to pass current. That's an AND gate. It has different logic, and we can do a lot of that for control. That's an AND gate. And there's also, I'm not gonna go too far into it, but how to physically make this AND gate. It's a combination between those two components to make decision. We have the other one, which is OR, which is mean either this on or off. This will be on. Either of those is on, it's gonna pass current. Yeah.
Do they make them so they do where they have the same inputs that you have there, but do the opposite?
Yeah, yeah. So if you take any
Those
kind
are
of
NAND
logic
and
control,
NOR.
you did electrical engineering or something, right?
NAND and NOR.
So electrical engineering, they will give you a small board. What do they call it? The breadboard.
Oh, I hate those things.
The breadboard, and you go and buy the gate and you stick it in, and you just try to experiment and see what happens. So those actually do work and do this function. And actually, I had a kit for electronics. I want to include it to the class, but it was too much. But I'll show you how it works. Triac. This is a triac electronic controls with 2 diodes and a single device used in switches as in AC circuits. Allow the current to pass in both directions when a certain current level is reached. So it's kind of a different kind of diode. I will show you some of these components just for fun. So if somebody is motivated or like interested in learning about this stuff, you can buy this whole kit for like $60, and you can build your own control system at home. And actually, this is the processor. This thing can control the whole thing. This is a complete computer. This can run actually Linux system. So you plug into this. This goes into your power. Actually, this power, this goes into your screen. Actually, you can run computer using this. This is the future. And then you have something called actually Raspberry Pi, which is more powerful. Again, it's $40, not that much. So if we look, this is what's called the breadboard. See the little pins? And you can make your own control for it. You can put a humidifier, you can put your sensors. All these are the components. LEDs,
This is basic stuff.
more LEDs, resistors, capacitors. Those are the ceramic things I was talking about. So what else? Oh, here's a transistor. I'm gonna pass it through so you can play with it. Small, tiny push buttons, pickup. So you can buy this whole kit, and there's also a LED display. It has a small motor, and I think this is a sensor for. Oh, this is the Bluetooth receiver.
No, cool.
You can connect this to your Bluetooth. And this is
And why is one of my car
What
big?
class were you gonna use that in?
building management, battery, power pack.
Building automation?
Yeah. And you can also do some little pack, bunch of wires, small motor, step motor. What does a step motor do?
It only goes
What?
so far to reach
Yeah.
a certain point.
So what do we use that for HVAC?
Step motor?
Yeah.
Maybe to open and close dampers possibly?
So if I do this with the AC here,
Oh, is it the
the vanes,
vein? Okay.
that's a step motor. So partially, just a little bit. Yeah, and this is actually called the Arduino. It's free. The software is free, and a lot of hobbyists like yourself can use that. It also have a GPS module in it.
What does it make when you're done?
Whatever you want it to make. You want it to measure distance. You want it to do input. You want to connect to Bluetooth. You want to connect to a Wi-Fi. Like all the controls you can see somewhere else, you can make this yourself.
With
Turn-
that kit?
Yeah, it can turn on and off lights. It can turn on and off motors. It can give you input. So, and a lot of the software is free, open source, online. So if you take a look at it. So this is gonna be part of. Bill used this for different control. He used different company. But these are very computer friendly. You can plug it into your PC and program it, and have it running by itself. So.
I think we should call it a day. My hand's tired. Writing so much.
Just because you said that, I can keep going. So LEDs, light emitting diodes, and it looks like a check valve. If you notice the symbol for a check valve, it's the same as the diode, so it means the current will go only through one direction. Huh?
Which direction? It's opposite of what you think, right?
Yeah. Isn't this way?
It depends
You gotta
on.
look at it,
It
right?
depends on the
Think
application.
so?
Positive.
Okay, so Tracy says this one.
I'm not positive. I know that's been like
I usually always check the label.
I always thought it was positive and negative.
It's
And
just,
then the other way is electron flow.
Oh, the board
That's what I
blinking
remember.
lights. But it has to be the right direction, because when I was working on those boards, if you plug in the diode the wrong way, it doesn't work. the LED light. Has to be a certain way. If you want any of those little LED lights in your home, if you want to change the bulb, it has to be the right direction. Unlike the other lights. Okay, thermistors. Okay, I'll stop now. Chris is tired.
Thank you. Can we go back?
Can you buy that LED?
Yeah.